Hola, ¿qué tal? ¿Cómo están todos ustedes? Ya casi nos falta un poco para el fin de semana. Hoy vamos a comenzar con unidad 6, lección 5, describiendo trends en un scatter plot. Vamos a ver si hay Okay, never mind. We're going to look to see if we have associations between variables, okay? So this first one, we just have 4 different graphs, and we're trying to identify which one does not belong. Remember, there is no right answer, okay? All of these are correct answers, but you just have to specify why, okay? So what I'm going to challenge you to right now, take the next 2 minutes, is figure out why each of these, you could say why they don't belong, okay? Okay, so hopefully you paused the video, and if you haven't already, go ahead and pause it so you can try to think on your own. But if not, I'm gonna go ahead and tell y'all what I think, okay? This first one is the only one that has a positive linear relationship, or I guess association, you could say. It's the only one that's positive. This one, why am I writing this one? Has an x-axis at 0. It actually has an x-axis. This one has hella outliers. Right, that's the word we learned yesterday. Look at all those outliers. Jesus. And then, why does the last one not belong there? LOL. No trend line. There is no line. So here are 2 copies. Oh wait, what? Your teacher will give you a piece of pasta and a straight edge. Yeah, totally. I gave you some pasta. Yup. And if you don't know what a straight edge is, just a fancy way to say ruler. But not like a ruler, like a king, like a measuring device. Here are 2 copies of the same scatter plot. Experiment with drawing lines to fit the data. Pick the line that you think best fits the data. Compare it with partners. Wait, what? Oh, I guess you're supposed to draw lines. So, I'm going to draw a horrible line. Okay, Derpy, what are you smelling? I was not grabbing other dogs. I'm going to draw a line. Damn, you going at it, huh? What are you smelling, Derpy? I'm not cheating on you. Okay, so that is not a line, but you can draw your own line. And then I'm just going to draw like a really wrong line or curve. And then obviously I hope you say this one's hella wrong, because it is go nowhere near the points, okay? Here are 2 copies of another scatter plot. Experiment with drawing lines to fit the data. Pick the line that you best think fits the data. Compare with the partners. So this is my line. Derpy, you're like sitting in front of the iPad. Derpy. Of course you don't pick me. Of course. Yep, Derpy. Okay, so that's the line that kind of goes through it, right? I'd say it's a pretty good line, okay? And then a really horrible line would be something like this. That line does not go through most of the points. So in your own words, describe what makes a line fit a data set well. So points are close to the line. Okay? The scatter plot both shows the year and price for the same 17 used cars. However, each scatter plot shows a different model for the relationship between year and price. Okay? We're looking at diagram A. How many cars does the model make a good prediction of its price? So we're looking to see how many points are very close to the line. So this is subjective, okay? You can count whichever points you think are relatively close, but I'm gonna say this 1, 2, 3, 4, 5. So I'm gonna say 5. And then how many cars does the model underestimate the price? I'm going to use green for those. 1, 2, 3, 4, 5, 6, 7, 8. Did I count right? Yeah. I'm going to do a sideways 8, because why not? And then how many cards does it overestimate the price? I'm going to use, what's up, Derpy? I'm going to use baby blue. Shark doo 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 doo. 1, 2, 3, 4 doo 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 doo. Ooh, you like that 4? Okay. And then looking at the same one, we're going to do the same thing. How many points does it predict it really good? None. I'll probably say 1, actually. 1. How many does it underestimate? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. And then how many does it overestimate? 1, 2, 3. For how many cars does the prediction made by model diagram A differ by more than $3,000? What about the model and diagram B? Bro. Oh, okay. So, to make things easier, we're trying to see where the residuals, right? Or where the differences are more than $3,000. So I just saw that from the line to this point, that's $3,000. So you're just checking to see where are the points more than a square. A square's worth. I guess you could call this a square. So that looks like 1, 2, 3, 4. For A. And then diagram B. Oh, hella. You got 1 here, 2 here, 3, 4, 5, 6, maybe 7. So, looking at this, which one do you think does a better job? A or B? Hopefully, you said A. Ha, you thought I was going to do B, huh? Ha, 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 ha. Got him. Is this a good line for the fit data? For the data? Explain your reasoning. Sure. Looks negative. I guess it could be better. Could be better. Draw a line that best fit the data. I think it would be something like this. Where like you kind of want to even out. I shouldn't be saying this, but whatever. I'm going to say it. No regrets. You want the outliers. You want the number of outliers. Sorry, not outliers. Residuals, negative residuals and positive residuals to be the same on both sides. So I know it's not perfect, but, it's better than this one here. Because, look, you only got 1, 2, 3, 4 on top, and then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 on the bottom. That's really outweighed. This is a good line for the fit. Yes. Number of outliers. Why do I keep saying outliers? Why do all that? Number of residuals, positive and negative, are about the same. Draw a line that best fits data. You know what? I'm going to cheat. Ha! Now they all go through the line. JK. Something like this. Oh, that's pretty nice. Are you ready for more? Sure. The scatter plots were created by multiplying the x-coordinate by 3, then adding a random number between two values to get the y-coordinate. The first scatter plot added a random number between negative 0.5 and 0.5. That makes sense. That's why the points are like super close to each other. The second scatter plot added a random number between 2 and 2 to the y-coordinate. The third scatter plot added a random number between 10 and -10. For each scatter plot, draw a line that best fits the data. Ooh. Wow, that's pretty good. Oh, this is going to be tough. Okay, not bad, not bad. Algo así. Good enough. Explain why some were easier to do than others. So which one was easiest? I also agree. A was the easiest. Which one was the hard? Sorry, A. These don't even have names. Let's just call them A, B, F. You thought I was going to say C, huh? So, A is easier. F isn't. But why was it difficult for like B and F? It's harder because this is what I would say. There's more spread. And not the good type that goes on bread. The points are much more random. If you were to like zoom out, they kind of look... No, they don't. See, now it looks like chocolate chip cookies. Ooh, how much can I go? Oh, this is... Woo! Hold up. Wait, can I write? Oh wait, that's too much. Can I erase? I'll stop. Zoom. Okay. So, that was it actually. So, when a linear function fits data well, we say that it is a linear association. Okay, let me change the color actually back. It's a linear association between the variables. For example, the relationship between height and weight for 25 dogs. Did we do this yesterday? Yeah, we did. With the linear function whose graph is shown in the scatter plot. Because the model fits the data well and because the slope of the line is positive, we say there's a positive association. For those of you who haven't finished the additional focus area on association and data, this is literally what the focus area is on. What do you think the association between the weight of a car and its fuel efficiency is? It makes sense that the more a car weighs, the fewer miles per gallon it's going to get because it has to use more energy and power to pull the car. So it makes sense that there's a negative association. Okay? Other than that, I hope you enjoyed today's video. Don't forget to hit like and subscribe or whatever it is people say nowadays. Also, turn in your homework.